Hello, everyone. In this tutorial, we're diving into chunking strategies for RAG applications, a crucial concept for improving retrieval accuracy in large language models. We'll explore different chunking methods and understand how they help identify relevant information efficiently. So let's begin by answering the key question. What is chunking and why do we need it? Chunking refers to the process of splitting large pieces of text, like documents, articles, or books, into smaller, manageable segments before feeding them into the RAG system. This improves both performance and relevance in search results. First, let's understand fixed-size chunking. This method divides text into uniform segments based on a fixed number of characters, words, or tokens. For example, imagine we have this large block of text. If we decide to break it into 20 tokens per chunk, the first chunk will contain the first 20 tokens, and the second will pick up from there. It's simple yet effective for structured data. Next, we have recursive chunking. This method takes a hierarchical and iterative approach. If the initial split doesn't produce chunks of the desired size, the method applies different separators, like paragraphs, sentences, or bullet points, until the chunks reach the desired size. For example, starting with large sections, we might later break them into paragraphs and, if needed, down to individual sentences. Now let's move on to document-based chunking, a method that splits text based on its inherent structure. For example, imagine a large document with headings, paragraphs, and sections. Document-based chunking can intelligently split the text by recognizing these structural elements. In code files, this method can even split based on class definitions, functions, or comments, making it highly versatile. Next, we have semantic chunking, which is all about meaning and context. Instead of relying on fixed sizes, this technique identifies natural breakpoints by analyzing semantic relationships. For example, consider a document split into sentence groups. Each group is passed through an embedding model to convert the text into vectors. By calculating the cosine distance between these vectors, we can measure their similarity. To visualize this, imagine a graph. Each point represents the similarity between one sentence and the next. If the distance exceeds a certain threshold, say 0.08, the 80th percentile, we create a new chunk. This method ensures each chunk represents a coherent idea, improving context retention. Finally, let's talk about agentic chunking, an innovative method that leverages large language models to mimic human judgment. Instead of relying on predefined rules, the model identifies meaningful points where ideas naturally shift, such as paragraph breaks or topic changes. For example, imagine a large text document. First, we prompt the LLM to identify key propositions or concepts within the text. Next, we use another LLM model to group those propositions into meaningful chunks. This method brings intelligence into chunking, helping the system better capture the flow of ideas. Okay, so let's start to go through the tutorial. So we would be going through the live examples of 5 core techniques for chunking. So let's first understand what is the principle for chunking. The goal isn't just to chunk data just for the sake of it. The true objective is to structure your data so it can be efficiently retrieved and utilized later. Let's go through the fixed size chunking example now. This checking has 2 major parameters. Chunk size, it is the length of the chunk, and second is the chunk overlap. It determines how many overlapping content is between the consecutive chunks. So let's say, for example, we have this text, and now we would be using LlamaIndex character text splitter, and we would be splitting with chunk size of 35, and we would be creating multiple documents. Documents would be the chunk here, so let's run this code so we can see the output. We have multiple chunks of 35 character each. Next, let's go through the chunk overlap. Overlap with 4 value means 4 repetitive, overlapping content between consecutive chunks. Next, let's go through one example of TikToking, which is provided by OpenAI. For example, LLMs have limitation of context token, limit of 8K, 16K, 32K, so TikToking can split the document into the chunks that fit within these limits. So we start using this by using character text expected from TikToking, and then just use. So this was the example using LangChain. Now let's learn how we can implement this with LlamaIndex as well. LlamaIndex is a framework designed for indexing, retrieval, and specifically for RAG applications. So we start by importing Sentence Splitter, we load the essay, which is a text file, and then we use Sentence Printer to split in chunk size of 200 characters with overlapping content of 15 characters between two consecutive. So let's print the first node so we can see the content with ID. This is the ID, and next we have this text content. Okay, so let's go through the example of recursive chunking now. In this technique, we keep a fixed size and it recursively split the text based on the different separators until the specified size is achieved. So for example, we have this text we will start by splitting using recursive chunking with a chunk size of 300 characters. The splitted paragraph is more than 300 chunk size, then it will go to the next step, which is use a different separator to break it down further. That's how it recursively keeps splitting the text. So let's print the document. Now here's the document content we have. It has created multiple chunks for it. Let's go through document structure-based chunking. So documents can be of multiple type. For example, Markdown, HTML, JSON, code-based. For example, we have this Markdown-based text content. We would be using Markdown node parser, which is provided by LlamaIndex, and we would be giving our document to it, so it will split the document based on multiple headings. So yeah, we can see the document node here. For example, if we have large code, then we can use code splitters, which are provided by LangChain and LlamaIndex as well. For example, this is the Python code, and we would recursive character text splitter, and we would be providing it the language. So this would be dividing based on the classes, function, etc. So we can go through the details on the supported languages and the separators based on each splitter here. Now let's go through semantic chunking. So this is taken from Greg's tutorial. All credit goes to him for this. So this is an advanced technique for splitting document into meaningful section based on the semantic similarity. So let's start by using an embedding model. So we are using embedding model by Google. For this, we would be needing Google API key. We can get it through Google Cloud. Next, let's create this embedding object and then just use Semantic Chunker from LangChain. Then we would be loading our asset document. So this is a very large document content. Now we would be using our Semantic Chunker to create multiple nodes from this large document. Then we can print the nodes here. Now we can see these are the multiple nodes which we have. Now let's go through the hierarchical node parsing with auto retriever in LlamaIndex. What it does, so for example, we have a large document. It would split that large document into a hierarchy where a parent node would have multiple child nodes. This kind of hierarchy structure it would contain based on multiple section paragraph chunks. So we can see it as a root node with multiple child node, and then that child has multiple child as well. So we have a complete tree-like structure here. So let's go through the example. We would be using this research paper of Llama 2. We would be downloading it next. Let's load the PDF file, and after loading the PDF file, let's create the hierarchical structure here. So we would be getting the nodes using this hierarchical node parser. Then we can see how many leaf nodes are there. Now let's start by loading these nodes into our storage. So we would be using Google's embedding model here. So let's create a vector database for this vector store index. Then we would be using auto-merging retriever to load these nodes, and then this node retriever would be merging the nodes based on the number of child nodes which are retrieved. So for example, this is our query string, and we would be searching this query string in our vector database using this auto-merging retriever. If we have multiple child node retrieved, then it would automatically replace them with the parent node. Let's start printing the retrieved node and the base nodes which we have received here. So we can see the example after merging the number of nodes are 4, and before that the nodes were 6. In this way, we can see all the nodes which we have retrieved in the content as well as the similarity with our search query. So there you have it. We've explored 5 powerful chunking strategies: fixed size, recursive, document-based, semantic, and agentic chunking. Each method has its strengths, and choosing the right one depends on your data and application needs. If you found this helpful, don't forget to like, share, and subscribe for more content on RAG applications and AI concepts. Thanks for watching, and see you in the next tutorial.